Welcome to my video on increasing and decreasing intervals. I'm going to go through three functions here. First one will be a quadratic, next will be a cubic, then a quartic. And we're going to try to determine where the function is increasing and where the function is decreasing. So before we do that, let's talk a little bit more about, when functions increase. That means that as we walk in, from left to right, we're walking this way. And we're going to sort of come in contact with our graph. So we first come in contact with our graph. I'll put our little guy up here. We come in contact with our graph here, right? If you were sort of to walk along this graph, you can see that you're going downhill. That's a decreasing function. And you reach this minimum point, the bottom of our valley, if you will. And then you kind of think about, you start walking uphill. Right? And that's where our function is increasing. Now, there are a couple different ways that we can sort of figure this out. We can use our graphing calculators to figure out this minimum value, and everything to the left of that, of course, will be decreasing, and everything to the right of that will be increasing. And the intervals are in terms of our x value. So it looks like this one is just our parent function here, y equals x squared, so our minimum value is 0, 0. So our decreasing interval would be anything that's from negative infinity to 0. And our increasing, the function goes up from 0 to infinity. All right, and these intervals are always open every single time. Alright, so that's kind of the way to do it graphically. If you wanted to, type this into your graphing calculators, let me clear that out. You'd go y equals x squared, and you'd graph it. And if we wanted to figure out that minimum value, I have a whole other video on this. It's only about a 5-minute video. You'd go second trace to the calculate menu, go down to minimum, press enter. It's going to ask you for a left-hand bound. You just want to get your cursor a little bit to the left of that minimum value. Right-hand bound, enter. So you can see these two arrows sort of that provides sort of the window for your calculator to look into. And then ask you for a guess. Just get it pretty close. You see that it's 0, 0. This one is, these numbers are really, really small, and it says e to the negative 6. Sometimes your calculator doesn't really know. It screws that up for some reason, but just know that those values are extremely small values, and we can assume that it's 0. We're smart enough to know that 0, 0, of course, is a point on our graph. You can see it in the table function right there, 0, 0. All right, that's the way to do it that's the way to do it graphically on your calculators. To find that minimum value, and then everything to the left is decreasing, everything to the right is increasing. But if you wanted to do it using calculus, you'd have to go and find your derivative. So the derivative says, all right, take that number, multiply it by the thing in front, rewrite your x, and reduce your exponent by 1. So that's your derivative, right? That tells us the slope of a graph at any point. Set that equal to 0 and solve it. So 2x is equal to 0, x is 0. That's our potential critical point. And we just write this function test. So the way that I set it up is I put that x value right here on this number line, and I say, all right, let's test something to the left of 0, and I plug it into my derivative. So if I test, negative 1, if I plug negative 1 in here, 2 times negative 1 is negative 2. So my derivative is negative, which means my function's going downhill. If I test something over here, let's test, maybe positive 5 or even positive 1 will work, doesn't matter. So 2 times, positive 5 is 10. So it's a positive number. Our function goes uphill when the derivative is positive. So when we have like a change between a negative and a positive right here, the derivative is negative, and then it turns from negative to positive at 0, that's a minimum value. So our decreasing function, our function decreases from negative infinity to 0, and it increases from 0 to infinity. Decreases, increases. Let's take a look at number 2 here. We have this cubic function. I think we've looked at this before. And we've said that, all right, this is our minimum value. it was like 0, -3. This was one we used in a different video. And our max value was 8/3, comma, I don't know, 6.48 or something like that. All right, so you're decreasing values, right? If you put yourself standing up here and you sort of come across this and you decrease, you walk downhill from, this is decreasing, -infinity to 0. Remember, we write x values here. So it's decreasing here, and then it increases here, and it decreases again over here. So it decreases from -infinity to 0 and 8/3 to infinity. We use this little union there. It increases from 0 to 8/3. That's where the function goes. It goes uphill. All right, and again, to find those using your graphing calculators, you just simply type this into y sub 1, go to that calculate menu, and find maxes and mins. You can also find your derivative. All right, I'm going to go lightning fast through this since I did it in the previous video. There's your derivative, set it equal to 0, and solve it. So I'm going to take an x out of there, and it leaves me with -3x plus 8. Solve both of them. X is 0. -3x plus 8 equals 0. And you see that's where I got that 8/3 from. And you put that on your number line. You say, all right, here's 0, here's 8/3. And I just do a function and a derivative test. To the left of 0 is -1, so I put that in here. -3 times -1 squared plus 8 times -1. That's -11, so that's a minus. The function goes downhill. Pick a number in here. It's anything between 0 and 8/3. Let's pick number 1. That's easiest. So we can see that -3 times 1 squared is -3, plus 8 is 5. It's a positive derivative. The function goes uphill when the derivative is positive. And over here you can plug in, you know, anything greater than 2 2/3, and you get the derivative is negative. All right, we'll test that quickly. Let's pick the number, I don't know, 7. So -3 times 49 plus 56. That's -120 something. It's definitely a negative number. I don't care what it is, I just care what sign it is. I picked 7 just randomly. You could have chosen 3 as well. 3 is certainly bigger than 8/3. But you can see that it goes downhill, uphill, downhill. So that literally gives you your intervals of decreasing. -infinity to 0, 8/3 to infinity is your decreasing, and then from 0 to 8/3 is your increasing. Sweet, last one. It's a 4th degree polynomial. So we're looking for intervals of increasing and decreasing, right? So I can tell right now, just if I highlight this thing, I can see that this goes downhill, this goes downhill, this goes uphill, and this goes uphill. So green goes uphill, that's not very good. Green goes uphill, purple goes downhill. Not super easy to see those exact values. Sometimes they're decimals, right? A lot of times they're decimals. So let's just type this into our calculators and start there. So let's see, we've got y equals, let me clear out what I had in there, x to the 4th minus 3x to the 3rd. I need to get some more space here. 3x to the 3rd plus 2x minus 3. So you get it all typed in there and you just graph it. And you can see pretty much what I have on my screen here. So I'll zoom in on it and I'm just going to simply calculate these values. I'm going to go second trace, which is the calculate menu, go down to minimum. Minimum is the 3rd option, I just press 3. So I'm going to look for this minimum right here. I'm going to go to the left of that, press enter. To the right of that, press enter. And then press enter on somewhere close to it. So I can see that my minimum value is about -0.432. 3.432, comma negative 3.59. Let's find this maximum value right here. So we have second trace, go down to maximum, which is the fourth option. Left hand bound, just get your cursor somewhere to the left of this max, press enter. Right hand bound, get it to the right of that little mountain, press enter, and then guess, get it somewhere pretty close. See 0.541, comma, I'm not really concerned about what the y value is. And now let's get to the other minimum right here, this minimum down here. So I press second trace, minimum is 3, so my cursor needs to be to the left of that minimum, press enter, and then go to the right of that, press enter, and then guess, press enter. 2.14. Notice I'm not really interested in the y values, because when we talk about intervals of decreasing and intervals of increasing, it's all about x values. Let's do decreasing first in purple, so it's negative infinity to negative, the x value here is negative 0.432, and then it picks back up again and it decreases from 0.541 to 2.14. All right, the green increasing values are from negative 0.432 to 0.541, and from 2.14 all the way to infinity. All right, if you're following along, these are the green ones and these are the purple ones, if you're a color-coded type person. And very quickly here, if you wanted to do the derivative of the function, you just get 4x to the third minus 9x squared plus 2. All right, if that is a little confusing to you how I got that, that's, derivative video, look for power rule. All right, we find the derivative because if we set the derivative equal to 0, that's where our tangent lines are going to be horizontal. All right, so these are, of course, potential maxes and mins, and then we just solve that thing. And when we solve that thing, we can get those three values. This one is a little bit trickier, but for this particular example, I just kind of relied on my graphing calculator and got those values. So there you go. 3 examples on intervals of increasing and decreasing. A little bit of calc involved, but for a lot of this stuff, you can either, if if it's a parabola, if you know the vertex, right, you can really easily see your intervals of decreasing and increasing, and those x values pretty simply. If you don't know the x values so easily, go to those graphing calculators and see if you can figure them out. But you should at this point be able to sort of visually see that the difference between where the function goes downhill, it goes downhill right here and here, and it goes uphill right here. So there you go, about 13 and a half minutes there, about 14 minutes or so on increasing and decreasing. I'm going to continue to record a few videos here this afternoon on some more calc-based stuff and learning how to sketch graphs and work more with first and second derivatives. So thanks for watching.